The Voyager spacecraft missions are among the most iconic and remarkable feats of human engineering and space exploration. Launched in 1977, both Voyager 1 and Voyager 2 have been traveling through the solar system and beyond for over 40 years. In that time, they have made numerous groundbreaking discoveries, revealed new insights about planets and moons, and even provided humanity with its first glimpse of interstellar space. These two spacecraft from the beginning were designed to explore the outer planets of the solar system, but they have far exceeded their original mission parameters, giving scientists a wealth of data and imagery that continues to astonish us to this day. The longevity and success of these missions have left many wondering how these spacecraft have lasted so long and what Voyager's most recent and perhaps most shocking discovery has been. The beginning of the Voyager missions was marked by an ambitious goal to take advantage of a rare planetary alignment in the late 1970s that would allow the spacecraft to visit Jupiter, Saturn, Uranus, and Neptune using a gravity assist technique. This alignment, which occurs only once every 175 years, enabled the spacecraft to slingshot from one planet to another without expending large amounts of fuel. Initially, the mission was to gather data on these planets and their moons, rings, and magnetic fields. Both spacecraft were equipped with cameras, magnetometers, plasma detectors, and a variety of other instruments to carry out their tasks. However, what made Voyager 1 and Voyager 2 unique was that they were designed with the potential to continue beyond their planetary missions and venture into deep space. Both spacecraft were equipped with nuclear-powered radioisotope thermoelectric generators, RTGs, which have allowed them to remain operational for decades. These RTGs convert the heat produced by the radioactive decay of plutonium-238 into electricity, providing power to the spacecraft's instruments. This power source has been the key to their extraordinary longevity, as solar power is not viable in the outer reaches of the solar system where sunlight is too weak. One of Voyager's earliest and most stunning discoveries came during its flybys of Saturn. Voyager 1 passed by the gas giant in 1980, followed by Voyager 2 in 1981. Saturn, with its majestic ring system, had long intrigued astronomers, but it wasn't until Voyager's close flybys that we truly began to understand the complexity of the planet's rings. Before Voyager's visit, scientists had thought Saturn's rings were relatively simple, consisting of broad, flat bands of material orbiting the planet. But the images and data sent back by Voyager revealed an incredibly intricate system of thousands of individual ringlets, some of which displayed kinks and braids. One of the most significant revelations was the discovery of the narrow F-ring, which showed structures that appeared to be constantly shifting, suggesting that the rings were far more dynamic than previously imagined. Voyager 2, which followed its sister spacecraft by nearly a year, was able to take a closer look at these features. With the benefit of Voyager 1's data, scientists were able to target specific areas of interest during Voyager 2's flyby, yielding even more detailed images and data. The spacecraft's instruments detected that Saturn's rings were composed mostly of water ice, along with smaller amounts of rocky material. The discovery of these dynamic, constantly changing rings forever changed how scientists viewed planetary ring systems and provided a new model for understanding the formation and evolution of such structures. Voyager 2 continued its journey after Saturn, reaching Uranus in 1986. Uranus is an ice giant and the seventh planet from the Sun, and before Voyager's visit, very little was known about this mysterious world. Its distance from Earth made it difficult to study with Earth-based telescopes, so scientists eagerly awaited the data that Voyager 2 would provide. What Voyager 2 revealed was nothing short of astonishing. The spacecraft discovered 2 new rings around Uranus, bringing the total number of known rings to 11. Voyager also found 10 previously undiscovered moons orbiting the planet. Perhaps the most surprising aspect of Uranus that Voyager uncovered was its extreme coldness. The planet's atmosphere was measured at a bone-chilling minus 353 degrees Fahrenheit, minus 213 degrees Celsius, making it one of the coldest places in the solar system. One of the most puzzling aspects of Uranus is its axial tilt. Unlike any other planet in the solar system, Uranus's axis is tilted by 98 degrees, meaning it essentially rotates on its side. This causes extreme seasonal variations on the planet, with one pole being in constant sunlight for half of its orbit, about 42 Earth years, while the other pole is plunged into complete darkness. Voyager's flyby helped to explain some of the peculiarities of Uranus's magnetic field, which also appeared to be significantly tilted relative to the planet's axis. But many mysteries remain. Years later, after scientists reanalyzed data from Voyager's flyby, they discovered that the spacecraft had actually flown through a plasmoid, a giant structure in Uranus's magnetic field. This was a significant discovery because it hinted at a previously unknown process in Uranus's atmosphere and magnetic environment, offering further clues about the complex dynamics of the planet. Voyager's journey through the outer solar system also brought it past Jupiter, the largest planet in our solar system, in 1979. Voyager 1 and Voyager 2 both passed by the gas giant, capturing a staggering number of images and data. During its flyby, Voyager 1 took nearly 19,000 images of Jupiter, while Voyager 2 snapped over 33,000 more a few months later. These flybys provided the first detailed close-up images of Jupiter's atmosphere, including its famous Great Red Spot, a massive storm that has been raging for centuries. The images showed swirling clouds and turbulent weather systems in Jupiter's atmosphere, revealing a planet that was much more dynamic and active than previously thought. Perhaps the most surprising discovery was on Io, one of Jupiter's moons. Voyager's cameras captured images of volcanic activity on Io, making it the first body outside of Earth known to have active volcanoes. These volcanoes spewed sulfur and other materials into space, creating a thin atmosphere around the moon. This discovery was groundbreaking because it showed that moons in the outer solar system could be geologically active, a possibility that had not been seriously considered before. One of the most iconic images taken by Voyager 1 was the pale blue dot photograph in 1990. After completing its planetary flybys, Voyager 1 was instructed to turn its camera back towards Earth and take a picture from a distance of more than 4 billion miles. The resulting image shows Earth as a tiny pale blue speck in the vast darkness of space, occupying less than 0.12 pixels in size. The pale blue image has become one of the most famous and profound photographs ever taken. It serves as a humbling reminder of the fragility and insignificance of our planet in the grand scheme of the cosmos. As the late astronomer Carl Sagan, who was instrumental in the creation of the image, famously said, "That's here. That's home. That's us." The image encapsulates the vastness of space and our small place within it, reminding us of the need to take care of our planet and to cherish the only home we've ever known. The Voyager missions have far exceeded their initial expectations. From discovering the dynamic rings of Saturn to capturing the pale blue image, Voyager 1 and Voyager 2 have transformed our understanding of the solar system and beyond. Even as they continue their journey through interstellar space, more than 14.5 billion miles away from Earth, the spacecraft are still sending back data, revealing new insights about the universe. The fact that these spacecraft, launched over 40 years ago, are still operational and contributing to science is a testament to the brilliance of the engineers and scientists who designed and launched them. The Voyager spacecraft are a symbol of human curiosity and exploration, representing our desire to understand the universe and our place within it. They have provided us with unprecedented views of the outer planets, their moons, and the interstellar medium. As they continue to travel further into the unknown, Voyager 1 and Voyager 2 will remain beacons of what humanity can achieve when we set our sights on the stars.